So let us discuss about wave winding in AC machines. This is a one armature used in our industrial applications. You can observe size of this armature. This armature has armature core, armature winding. This armature core has the internal slots. Last class we have discussed different types of slots and different types of conductors used in our armature windings. Let us recollect what we have seen previous classes. AC wave winding. In last class we discussed AC lap winding. In that case we have compared a DC as well as AC windings. In DC machines we discussed it as a winding diagram. In addition to this one, we require some commutator segments connections. At the same time, we required to place the brush positions. These are some steps involved in a DC. But whereas in case of AC, so we are going to draw only this winding diagram. No commutator presence in AC, no brush position is required, simply draw this AC winding. So very easy as compared to the DC. Okay, now at the same time we have seen that in AC, so we require the one slot pitch angle is a very important. So why? So in AC windings there are more than one winding in AC machines, as in the case of split phase motors, capacitor motors, capacitor start motors, capacitor run motors. So in single phase as well as in three phase motors. So the slot pitch angle is very vital role. So we have to find that what is the slot pitch angle. It is what is that one? The slot pitch angle is the angle in electrical degrees between any two adjacent slots. So we can calculate it previously. So what is the slot pitch angle? So that means here this is a one slot, this is another slot, this is another slot. So here what will happen? So in AC windings we already studied. So here single phase as well as the three phase motors. In single phase motors, unfortunately these motors are not self starting motors, whereas the three phase motors are the self starting motors similar to the DC machine. But in single phase motors like the split phase motors, and where we required two windings, one running winding, another is the starting winding is required to make our machine's initial starting purpose. So that's why I required these two windings is required. Okay, at the same time, so we have to calculate this the slot pitch angle. So this angle, this is slot angle, that's when the we can see the slot pitch. At the same time, I want to know that what is the angle. Okay, so I am going to calculate that this thing. So first of all, what is the slot pitch angle? The slot pitch angle is equal to, we can write it directly, the 180 degrees. So each So phase displacement with the two coil sides 180 degrees divided by the slat pitch. Okay, slat pitch. And what is the slat pitch? The slat pitch is equal, we can write, already we know, slat pitch is equal to, so total number of slats divided by total number of poles. So total number of poles. Then as per the given data, how many slats in a given machine and how many poles designed for this one. So we are going to calculate a slat pitch. If the slat pitch is known, so we are going to substitute here. So we are going to get the what is the slat pitch angle. Okay, so slat pitch angle, so I can easily calculate. Okay, slat pitch angle we can easily calculate it. It will give us some idea. Okay, so we discussed this all things. Now let us see the what are the regarding to the AC machines once again. Machines in AC site. AC machines, you can see machines in AC. So we know that some machines capacity from fraction of watts to some hundreds of kilowatts we are using in our electrical field for various applications. You can see this is a HP, maybe 1000 HP. This may be so fraction of HPs, and this may be hundreds of HPs. So here, comparing to the DC, our AC machines are cheap and best and rugged one. So this can be designed for various applications. So hence, to run any motor, we require some armature. How the armature winding is wound in a armature core. So whether it is a lap winding, whether it is the wave winding. Okay, so you can see few more AC machines. So you can observe these all are the AC machines. Okay, so single phase as well as a three phase. If you observe, this is a single phase. Okay, so the capacitor start motors, and this is a single phase, this is a three phase motor. Okay, so for general purpose this can be used for the some pumping purpose. And so you can see few more machines used in our electrical field. Okay, so how these motors, you can see this is one of the split phase motors generally observed in our laboratories. Okay, capacitor start single phase induction motor, and this is a three phase induction motor. You can observe this type of the motor used in our agriculture pump sets. Okay, and so you can see this what is the difference between the AC motors and DC motors, already we discussed. So at a glance, in AC motors, so there is no commutator, whereas in DC motors there is a commutator, and at the same time armature is the rotor in case of the DC motors. Here armature is the stator in case of the AC motors. Okay, whether rotor is whether it may be wound rotor or squirrel cage rotors. Okay, so here the main difference is this one, but at the same time, so 75% of machines are AC motors only, whether it is a single phase or a three phase. So only so few percentage of the machines are DC machines, because the DC machines are the costly and maintenance also is required more. Hence, so we should know as an electrical student how to wound our winding on a armature. Okay, whether this AC motors may be synchronous machines and induction machines, whether single phase or three phase. Okay, so these all are the single phase motor generally you can observe in our domestic applications in pumping the water from the municipality water sump to our overhead tank. And you can see this is one application of the AC machine, so generally used in our domestic is a mixie, and inside there is a AC motor, but it has AC motor only. This motor has the commutator and brushes also, but it can operate it AC as well as the DC. Hence we can say the inside motor is a universal motor, high speed motor, 3000 rpm it can run. Okay, so now you can see this is our very known motor. This is a single phase motor. Okay, single phase split motor. It has two windings, starting winding and running winding. So this is also one important AC motors. And this is a cooler. So you can desert cooler. It has two machines, AC motors. So one is a fan, another is a pump. So both are operated in AC supply. Okay, now you can see this is the another important machine inside, that is the compressor. The compressor also has the armature winding, and inside you can see, so it is also operated on AC supply. Okay, so refrigerator, air conditioner, anything you can take, domestic applications. So most of the applications are AC. Hence we need to how this winding wound on a armature in the stator part. Okay, let us see in details. AC windings. The AC windings are classified further: a single phase layer, a single layer winding diagram, and concentrating winding diagram, and double layer winding diagram, the integral slot winding diagram, and fractional slot winding diagrams. These are the few classification of AC windings. So mostly our winding diagrams are the single phase and single layer and double layer winding diagrams, in which we are going to use the lap winding and wave winding. So whereas the concentrating winding can be used in for transformers. Okay, so there is no pitch factor. So there is a full pitch and this is a distribution winding. Okay, so integral slot winding and fractional slot winding is a special purpose of machines designed in industrial purpose. Okay, so here we are going to some majority of windings are lap winding and wave winding, whether a single layer or multi layer windings. Now what do you mean by the wave winding? So already you have observed, we have seen the wave winding in DC machines. Similarly in AC machines also same principle. An armature winding in which the coils are laid into layers and follows each other one on the surface of the armature in the form of waves. Okay, so you have already seen. So what we have seen, so for example, these are the few conductors are placed in the armature slots. For example, if I started from one slot, it is connected to the at a pole pitch 180 degrees electrical, and this conductor, once it will goes to the as a full pitch coil, the front pitch it is going to the this way, and it is connected to the next another way here. So it is going to the similar wave. So that means here you can, this is known as back pitch, and from this to this we can say this is the front pitch. So just like this is a wave we discussed in previously. Okay, so that means here what has happened, so an armature winding in which the coils are laid in two layers. So because here the number of parallel paths A is equal to 2, whereas in that case a lap winding, the number of parallel paths equal to the number of poles. If the poles are 2, 4, 6, 8, then number of parallel paths increased in case of the lap winding, where we require the high current, low voltage. But in case of the wave winding, we required more voltage and less current. That's why here, so independent of the number of poles, whether the number of poles may be different, but total number of parallel paths are only 2. Okay, so 2 number of parallel paths. So that is here. So surface on the armature in the form of waves with a coils being so connected in series that there are only two paths for the flow of current, whatever the number of poles in the machine. Okay. So this is when, let us see one diagram. Now you can see. So here what will happen? So red color, this is one coil, and this is a top. This each coil consists of two conductor sides, coil sides. This is a one conductor and this is another conductor. Okay, the coil consists of two coil sides. This one coil side is placed under the influence of north pole, and another coil side should be placed under the influence of south pole, that is the 180 degrees apart at each the pole pitch. So you can see the red color is a solid one is indicated the top one, and dotted one indicated the bottom and a slot 2-layer winding. Okay. Now here the red color. So let us take this is under north pole. Let us assume here is one conductor. This conductor is connected here the slot, and at the back pitch it is connected to the under influence of the south pole. Here is connected here. Then it should be connected to the next coil, which with the front pitch gap. So it is connected to another second coil where it is placed at a 180 degrees displacement, so north pole. Now it is once again it is connected to the another coil. The second end of the second coil is connected under the influence of south pole, such a way that it is represented as a wave. Okay. So now you can see the one practical example. This is a armature, and this is a winding. You can see it is connected in the form of wave winding. Okay. So just like it is connected in series. It's a wave winding. So you can see the one armature. So here it is the stator. Okay. So this armature and armature slots is generally used in our industry. Now let us take one example how to draw the wave winding in AC machine. So that purpose we have required some steps to complete our diagram. So single layer wave winding, dear students. So for development of simple wave winding, we have to follow steps. One is the simple calculations for pole pitch, back pitch and front pitch. After knowing these main pitches, then prepare the winding table based on these factors. Then after completion of the table, then draw the winding diagram. Okay. So these are the 3 steps involved to complete given problem. Let us assume here is one problem is given, here is one constraints is given, question is given. So in a machine, what is the machine is given? Here let us take one example. So here, so develop a wave winding for a single phase AC machine having slots, 24 slots. So given the slots are, number of slots are given 24 of one conductor per slot, each conductor placed in each slot. That means, so we are going to get the number of conductors, total number of slots 1, each slot is the one conductor side, that is equal, total is the 24 conductors, and number of poles P is equal 4 pole machine is given, and we are going to develop the wave winding with a progressive winding. So these are the some constraints is given, dear students. Okay. So we will draw this winding diagram. Okay. So let us start it. First step, what are the first step? Simple calculations for pole pitch, back pitch and front pitch. Now development of simple wave winding. So first step is the calculation of the back pitch and front pitch. So before going to this one, what are the salient points regarding to the wave winding? So here the back pitch and front pitch must be odd and equal to the pole pitch, and back pitch and front pitch equal or differ by 2. and here the resultant pitch is equal to back pitch plus front pitch, whereas in lap winding the resultant pitch is called back pitch minus front pitch. Now, so based on this one we are going to calculate this one. So first, what is the pole pitch is given. Okay, so for the simple calculations, so we know the pole pitch is called total number of conductors by number of poles. Okay, so next, so what is the jet total conductors? So 24 by 4. Okay, so for example, you can do the first step is the simple calculations. Simple calculations, YB and YF. So we know that calculations regarding the year. So what is the pole pitch? First of all, you calculate the pole pitch. The pole pitch is equal to total number of conductors divided by the total number of poles. So total number of conductors is given the 24 divided by 4, then we are going to get the 6. Okay, 4 ones are 4, 6 are. So then pole pitch is we are going to get it. So here 6. In wave winding, so both back pitch YB and front pitch are same and even numbers. Okay, so that's why we taken the YB is equal 6, then YF is equal to 6, and both are even numbers. These are the simple calculation, dear students. After knowing these calculations, then you calculate the goes to the second step. Okay, so what is the second step? Next, the back pitch front pitch is equal to, so 6, hence we taken this one. This is the simple calculation. And second step, so second step is the development of simple wave winding. Prepare a winding table based on back pitch and front pitch. Here back pitch and front pitch, take this table similar and prepare the one table. Okay, let us do manually the winding table based on the YB and YF known. Okay, for this purpose, so I am going to calculate, so first serial number, back pitch and front pitch. Okay, you take the table, so you draw the one table here, and based on this table you prepare the winding table. Okay, now serial number 1. Here what is happened? Serial number 1. So we have these windings. So conductors 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up to 24 conductors. Okay. So now these conductors, let us start one conductor from this one slot 1. So I started 1 plus YB is equal 6 and YF is equal 6. Okay. So here 1 plus 6, I am going to get it 7th. So I am going to connect one pole pitch at the 7th conductor. Okay. So for example, we take in this is the one pole, this is the another, and this is the, similarly we are going to this one. Okay. So this is the 7th. Now 7 plus 6, because wave winding 11th conductor, I am going to connect in the another pole pitch 11th conductor. Okay. Second step, in here going to connect it. So next I am going to connect, what is this one? So sorry, 6 plus 7, 13 now. So I am going to connect the 13th, sorry, 13th. Now so 13th plus 6, so 19 I am going to connect. I am going to connect the 19th one pole pitch here. Okay. So 19 plus 6, that is equal 25 conductor. But I have the only how many conductors? So I have the only 24 conductors. Okay. So 24 conductors. So there is no chance. So 24 conductors is nothing but the first conductor. Okay. I have to connect the here 25th conductor. 25th conductor is nothing but, so 24 minus 1, so first conductor as usual. But already this first conductor in the first slot is engaged this with another coil. So there is no slot empty for this first conductor in the first slot. Hence here you have to change one technique. So instead of 19 plus 6, you have to write it here 19 plus, you add it one step above. Okay. So here you are going to write it, so 7, then you are going to get it is a 26. Okay. So dear students, so here what will happen, you have to take this one step. If one side of the coil is placed slot number 1 previously, the other side of the coil should be placed in the slot number 1 plus 6, that is a 7. Okay. So the finishing end of the coil side at slot number 7 is connected to the starting end of the coil side at slot number 7 plus 6, that is equal 13. Now the other side of the coil side at slot number 13 is placed at slot number 13 plus 6, that is in 19. Adding 6 to the slot number 19 gives the 25, which is the slot number 1. So that is equal to, but a coil side is already placed at slot number 1. So there is no scope to add. So here what will is given constant, one slot for one conductor only. Already that one slot the filled with the conductor 1. Once again, so here AC winding is the open winding, not closed winding. Okay. Then what to do? So that purpose you add 1 and place the coil side at slot number 2. So here adding the 6 plus 1 7, 19 plus 7, we are going to get the 26. The 26 minus 24 minus, we have the only 24 slots. The 24 minus 26, then we are going to get the second. So that means here this end we are going to connect in the second conductor in the second slot. Okay. So this is the twisting point, dear students, you have to remember. Okay. So just advanced by the 1. Similarly, add turn by turn back pitch and front pitch and complete the total winding diagram. Okay. So here, so 2. After that, so you are going to get the same 2 plus 6 is equal 8. Okay. Similarly 8. Now 8 plus, so we are going to 8 plus 6, that is equal to, you are going to the 14. And fourth, the 14 plus 6, 28. Yes, we have the 28th conductor. 20 plus 6. Here I am going to get the 26. 26 with second conductor. Second conductor means already filled here. What to do? So we have to add one more spoon. So instead of 6, you have to add the 7 here. Okay. So then what will happen? So we are going to get the 27. The 27 is nothing but third conductor. Okay. So you are going to start here. Okay. So every 2 steps you are going to listen here. Fifth one. Now 3 plus 6 is equal to 9. 9 plus 6 is equal to 15, and 15 plus 6 is equal to 21. Here you can observe 21 plus what to do. So instead of 6, you have to add the 7. Okay. So that is equal to 28. 28 means the fourth conductor. Okay. So every here step here, every second step you have to, and that means, so what will happen? So after one completion of year, so a completion of year, so what to do? You plus add 1 point. After completion of this one, what to do? So add 1 plus 1. So every time you are going to add, so in front pitch add 1 plus. Okay. So similarly we complete the total table, dear students. So let us complete this table for once again for the clarity. I have made one animation for you, you can see it. Now, so this is the table. Then I started first starting 1 plus 6, back pitch is equal 6, front pitch is equal 6, 1 plus 6 is 7, and 7 plus 6 is equal 13, and after 13th it's connected to the 6th, that is the 19. 19 plus 7 is the 26. So instead of 26 I taken the 2. Okay, this is the twisting point. Now after completion of this one, 2 plus 6 is 8, 8 plus 6 is 14, 14 plus 6 is 20. Next here the point 20 plus 7, you have to add the 1 point, that is we are going to the third conductor. 3 plus 6 is called 9, and 9 plus 6 is called 15, and 15 plus 6 is called 21. 21 here point 21 plus 7 is we are going to the 28, that is the fourth. Now similarly the 4 plus 6 is equal 10, 10 plus 6 is equal 16, 16 plus 6 is equal 22. Now 22 plus 7 is equal, that is 29. So we can represent as a 24 minus 29 is equal fifth. Okay. Now 5th plus 6 is equal 11, 11 plus 6 is equal 17, 17 plus 6 is equal 23. Now the 23 plus add 1, that is a 7, that is equal 6. 6 is the 6 is how we are going to get 6, the 24 minus 30. We have no labeled 30 slot or conductor. That's why we have subtracted 24 minus the 30. We are going to get the 6. Now 6 plus 6 is equal 12, 12 plus 6 is equal 18, 18 plus 6 is equal 24. So 24 is the last conductor, dear students. It is the finish. We started the starting at conductor 1 and we finished conductor last conductors. We have the only 24 conductors, 1, 2, so we have the 24th conductor. Okay, so this is a total winding diagram, dear students. Okay, it's a very simple. Now after getting this winding table, let us enter into the third step. What is the third step? Now this is the winding table. Now based on this winding table, so we are going to enter the third, that is a develop a winding diagram with the help of the winding table. Okay, so here, so you have to draw the lines as usual. So draw the main winding diagram purpose, draw a solid lines of equal length and equal distance, the equal to number of slots is drawn based on the given data. Okay, so after that, so label the number of conductors top and bottom. Okay, so 24 slots. Now, so how many poles represent the number of poles also. Here arbitrarily assume a particular current directions to the coil sides under the pole pairs. For the coil sides under the north pole, so we regions assume the downwards current directions and vice versa for the south pole regions. Okay, so this is a routine works, dear students. Now what is the next thing? I am going to connect based on the table diagram. That means after completion of this one, I am going to connect it. Okay, so what is the connection? Already you know, very familiar. So based on the table, okay, based on the table, so I am going to connect this one. So let us start the first conductor. This is the first conductor. So started here and entered in the first conductor in the first slot. So what is the pitch? It should be connected 180 degrees. This is starting up this one, connected here. Okay, so 1 plus 6 is a 7, the back pitch. This is the back pitch. Now we require the front pitch. So front pitch is equal 7 plus 6, that is equal 13th. Where is the 13th? Here is the 13th. So you connect the 13th conductor here. Okay, now after 13th conductor you have to go. So 13 plus 6 is a 19. Where is the 19? This is the 19. Okay, so 19 plus 6, that is going to the 1. Already it is a completed one. So you have to add it. Okay, so here that is the twisting part. We are going to connect. This is the, instead of first conductor, you have to connect to the second conductor as per table. Okay, so this is a one diagram. One round of the connection is over. This is the first wave. Okay, it should be connected to the second. Now in second I am going to connect second, this is a second conductor. Okay, so entered here. The second conductor should be connected. Once again start. What is that one? 2 plus 6, eighth conductor. You are going to connect the eighth conductor here, eighth conductor. Now 8 plus 6 is a 14. Now we are going to connect. So 14th. Where is the 14th? This is the 14th. Now 14 should be connected where? So that 14 plus 6 is a 20. We connect to the 20th conductor. This is the 28th conductor. Okay. So 20 is connected to the where? So we are, instead of once again 2, add 1, 20 plus 7, that is going to the third conductor. So we are going to connect, this is in third conductor. Okay. So now third is ready, and third is 3 plus 6 is called 9. So it should be connected to the 9 here. Okay. So 9 plus 6 is connected to the 9 should be 9 plus 6 is called 15th. So we connect to the 15th. So this is the 15th. The 15th is connected to 15 plus 6 is 21. So here the 21 conductor. The 21 plus 6 is equal to, we are going to 27. Already 3 is engaged. So plus 1. So 21 plus 7 is equal to 28. That is equal to fourth conductor. So we have to connect. This is equal to the fourth conductor. So where is the fourth? This is the fourth. Okay. So 4 plus 6 is the 10th. So it should be connected to the 10th. Where is the 10th? This is the 10th. Okay. The 10th is connected to where? 16th. So going to the 16th. Okay. The 16th is connected to where? 16 plus 6 is 22. So this is the 22. Okay. So 22 is connected to the, as usual, the fifth conductor. It should be connected to the fifth conductor. Where is this fifth? This is the fifth conductor. Okay. The 5 plus 6 is equal to 11. So you are going to connect the 11th. Okay. So 11th conductor is connected to the 17th. So you are going to connect 17th. Yeah. The 17th is connected to the 7 plus 6 is 23. So you are going to connect 23. Okay. So 23 is connected to, as usual, that is equal sixth conductor. Okay. Here represents sixth conductor. S6 entered. The 6 plus 6, the 12th conductor. So just connect the 12th conductor. This is the 12th conductor. Now 12 plus 6 is equal to 18th conductor. We connect to the 18th conductor. Okay. 18 plus 6 is equal to 24. So we are going to last conductor. So this is our final finishing conductor. Okay. This is starting conductor. This is a finishing conductor. So this is a total winding diagram, dear students. It is very simple. I think you have understood this easily. Okay. So once again, so you can see this diagram, so with animation. Okay. So based on the table, simple connection takes place. Okay. So but how you are going to connect? So let us see this one, animation first. So these are the all lines drawn parallel. Okay. So in equal distance you place it, so without any confusion. Draw the parallel lines with equal space and equal to the number of conductors. Okay, we have drawn. So for the avoid the confusion, I have drawn the blue and red colors. No need to write the colors. Just you have the draw the with pencil. Number them from left to right and select any slot for starting purpose. So what is the numbers? So 1 to 24. I taken the odd numbers, the top and bottom are the bottom for the even numbers. Then represent the number of poles. So north pole, south pole, north pole. So we know the pole pitch. So each pole consists of the 6 conductors under influence. You can see it. Let us arbitrarily assume the current directions in the conductors. Okay. So let us assume the north pole we taken is the downwards, south pole is the upwards. So this is a routine work. Now based on the table diagram, start from the conductor 1 in the slot 1. Okay. So I connected, we taken the start conductor 1, and with the pitch 1 plus 6, the 7th conductor, I connected at a one pole pitch 180 degrees. Now 7 plus 6, so I am connected the 13th. 13 plus 6, 19th. 19 plus 6, so I am going to connect. So instead of 1 already is engaged, so that purpose 19 plus 7, so I am going to connect the second conductor. You can see indication second conductor, not first conductor. This one round is over. Next, enter the second conductor, and 2 plus 6 is 8, 8 plus 6 is equal to 14, and 14 plus 6 is equal to 20. Okay, so the 20th is connected to the third conductor. You can see here the third plus 6 is equal to 9, 9 plus 6 is equal to 15, 15 plus 6 is equal to 21. You can see 21, and that should be connected to the 21 plus 7 is should be connected to the fourth conductor. Okay, next the 4 plus 6 is equal to 10, 10 plus 6 is equal to 16. Okay, 16 plus 6 is equal to 22, and 22 plus 7 is equal to fifth conductor. I connected. Now the 5 plus 6 is equal to 11, and 11 plus 6 is equal to 17, and 17 plus 6 is equal to 23, 23 plus 7 is equal to sixth conductor already known, and 6 plus 6 is equal to 12, and 12 plus 6 is equal to 18, 18 plus 6 is equal to 24th. This is the final connection. Okay, so very easy, dear students. The wave winding is the clarity, there is no confusion, but you have to indicate these numbers here. Okay, indicate the where you are going to the this one, and indicate these numbers, important. Okay, so these are the very clearly we have written. Okay, so this is final winding diagram. No need of the slots, no need of the commutator segments, no need of the brush positions. Okay, so where we are going to use this winding? So we are going to use this winding in our machines, armatures. So if you observe, this winding is wound in the form of wave winding. How we are wound this one? So similar this way. Where we are going to use this armature? We are going to use this machines for the different applications where we require the high voltage and low current required. We can prefer this wave winding. Okay, I think you have understood how to draw the wave winding in a single phase AC motors. Okay, dear students, if you are having any doubts, so goes through our textbooks. Okay, thank you for listening my class. So what we have seen, so let us conclude what we have discussed in this class. So first we have seen what is the wave winding. We have compared DC windings and AC windings. We discussed how many types of slots present in AC winding. After that we calculate what is the slot pitch angle. Then so based on our knowledge, like based on the given constraints, we have taken one problem and we calculated firstly simple calculations. After that we have prepared the winding table based on the back pitch and front pitch. After that, so based on this winding table, simple I connected all lines for completion of winding table. Okay, so this is a complete winding table procedure, dear students. Okay, so practice with your drafter on a paper sheet. Okay, thank you for listening.